Today we are going to go over decimal basics. Basically, what decimals are, how they work, and just a general overview of them. So basically, decimals are another way, along with fractions, of representing numbers that are between whole numbers. So right here we have 34, right? That's whole number. 3 is in the tens place, 4 is in the ones place. Now, if I put this dot here, that's called a decimal. Technically, there's an invisible decimal after every number, just like there's an invisible 1 in the denominator of every whole number. But it is 34, and now if I put this here, it becomes 34 and 3/10. So this 3/10 right here is actually equal, so I can also write it as, this is just the 3/10 with 0 as the whole number, 3/10, and that is also going to equal the fraction of the same name, which is 3/10, right? Now, if I go here, so this, the first number after the decimal is tenths, the next number is 3/100ths. So this would be hundredths. And that would be equal to the fraction of the same name. So it is important to know how to name decimals and fractions, because if you know how to name a decimal, you can just write the fraction of the same name, right? This is 3/100ths, and this is also equal to 3/100ths. Now the next place value is thousandths, which this would now equal 3,000, right? So it would be 3 over 1,000 in a fraction. Okay, so that is in the most basic form how decimals work. Now, there are a couple of things to note here. One is that if I continue to draw zeros after a decimal, like I am now, it does not change the value of the decimal. So, adding these zeros, technically I could add an infinite amount of zeros after the decimal, and it will not change the value of the decimal. As long as the zeros are after the decimal and there are no whole number, or there are no digits other than 0 after the 0. Like if I were to put another digit here, like if I were to put a 4 here, then obviously we need to keep these as placeholders. But if the 4 is not there, and it's just zeros from here on out, then it doesn't matter. And the reason that is because we can do 3/10 equals 3/10. Then we can do 30/100ths, right? So you're always going to say the number, and how you pronounce the decimal is you say the number that is the decimal, right? This is 30, the number after the decimal place, and then you say the place value of the last number. So this would be hundredths, so this would be 30/100ths, and this would be 30 over 100, or 30/100ths as a fraction, and then we can add 2 zeros, and it would be 300 over 1,000. And 300 thousandths. And just as these decimals are equal to the same thing, these fractions are equal to the same thing, right? If I multiply this by 10 over 10, it would give me 31 hundredths. Or if I multiply it by 100 over 100, it would give me 300 over 1,000, right? So they are all equivalent. Now, the reason that this is important is because if you're comparing fractions, like we do sometimes, you might want to just add zeros to make it clear what you're comparing, right? So if I want to compare 4/10 and 4/100, then what I can do is add a 0 here, and now we can see that we're kind of comparing 40 hundredths to 4 hundredths. Obviously, 40 hundredths is going to be bigger. So I think I'll probably make another video about how to just comparing decimals at some point, but this is kind of the basics of decimals. It's just continuing place value to the right of the ones place, basically. Hopefully that video was helpful and clear.